In the last video, we had looked at how two factors like x plus 3, make that clearer, and x minus 2 could be distributed to give us a result of x squared plus x minus 6. And we had then turned around and looked at how we could take the result, x squared plus x minus 6, and factor it. So we know how to go back and forth both ways. And the basic method for that was to simply look at the factors, possible factors of 6, which would be 1 and 6, and 2 and 3, and I should say the possible integer factors. So those would be all of the possible combinations, and we considered how to put those together. And in this particular case, 2 and 3 were the appropriate factors. We knew that we would need to have one of them being subtracted or with a minus sign in order to get a negative 6. And we knew that the difference, therefore, between them had to be plus 1 to match the implied coefficient for the middle term. Now what we want to do is look at slightly more complicated cases. Okay. So if you were going to go back to talking about this in the form ax squared plus bx plus c, what we looked at above was the case where a is equal to 1. So the last video was only concerned with cases where a was 1. In other words, there's an implied 1 in front of the x squared. So all we really had to worry about were the factors of c. Now, if we consider another case, like 2x minus 1 times x plus 5, if we expand that by the usual methods, we get 4 terms, since it's a binomial times a binomial, which are 2x squared plus 10x minus x minus 5. And when we combine those terms, we end up with, or combine the like terms, we get a single middle term that looks like this. Okay. Now, if we had originally just been given this, we could turn around and factor it. And in other words, go back to what we have here. Now, the trick to factoring this would be to recognize that we actually have a couple different factors for a. The a has a value is 2, so that could be composed of a factor of 1 and 2. That's the only possibility in this case. The c term also only has one possible factoring, which is 1 and 5. Okay. Now what we could do is simply now use a method of guessing and checking for all of the combinations. So there's really one combination for the of ways to factor A and one way to factor B, but we need to figure out how to match those up. So if I didn't know the original information, so pretend this is a question mark here, and I was trying to go back to figuring out what those factors were, I could say, well, we know that we have to have x in the first factor and a 2x in the second factor because we need to be able to get a 2x squared when we multiply through. Or it could be 2x in the first and 1x in the second. Now the question is, what do we do with the 1 and the 5? The 1 could be in the first factor or it could be in the second factor, so there are two possibilities here. But so we can easily figure this out by what we could call guess and check. So in order to complete this, we first of all should look at some signs here. We know that the 5 has to be a negative 5, so the 1 and the 5 have to have opposite signs, or you could consider adding one and subtracting the other. And when we need to be able to get a middle term that's positive 9x. So there are a couple of things you could try. You could try minus 1 here, and you could try plus 5 here and see what happens. When you do that, you would see you only have to worry about what the middle term would end up being. You would have a minus 2x and a plus 5x, and the minus 2x and the plus 5x would give you a 3x, which is clearly not 9x. So that's the wrong combination. So let's try a different combination. Let's try, we could turn around and just change this to plus and the other one to minus, and see what happens there. If we do that, then we would have a minus 5x and a plus 2x, which is just the opposite, or negative 3x. So with switching the sign simply changes around the sign of the middle term, and since we want a 9x, not a 3x, neither of those combinations work. So we can eliminate that as a possibility. Since those two possibilities don't work, we could try, let's do this. Let's try a plus 5 here and a minus 1 right here. And lo and behold, it's going to work because we have a 10x and a minus x, which would give us a middle term of plus 9x. And knowing what I did about the equation, I knew that I wanted to have a positive 5 times the 2x because I wanted to have a large positive term, and I wanted to have a small negative term in order to end up with a positive result. So let's look at a couple more examples and use the guess and check method. So here is one more. This time I'm not going to give you the original, what the factors were. We're going to start with an expression, 6x squared plus x minus 12. So we need to figure out how to factor this. So when you look at this one, we can look at the 6 and we can realize that this could be a 1 and a 6. Or if we continue, it could be a 2 and a 3. And the reverses of the reverse of those will work as well. So we won't list 3 and 2 and 6 and 1. 12, on the other hand, that has several factors that we could use. We could factor that into, let's see, we could go 1 and 12. We could go, 2 and 6. I almost forgot that one. And we have 3 and 4. And once we get to 2 that are just 1 apart, we know we've reached the end. So those are the possibilities. Now, this one would be a lot trickier to do by guess and check. In fact, this is a terrible candidate for guess and check. Because if we look at it, there are 2 combinations over here. And for each of those 2 combinations, we have 3 possibilities over here. But assuming we write the first in the order shown on the left, we have to consider all of the possibilities on the right in both orders. So we would have to consider the 1 and the 12 and the 12 and a 1. So if you turn around and multiply 2 times 3 times 2, we have to try 12 different combinations. So that's a lot more work than the last case. So this would be guessing and checking is not efficient at all. This is inefficient. So we are going to want to come up with a better method for doing a problem that has that many combinations. So let's look at one last problem where the number of combinations isn't so high. So let's consider the expression 4x squared minus 8x plus 3. This is more complicated than our first example, but less complicated than the example that we just did. The reason why is 4 could be factored 1 and 4 or 2 and 2. The 3, on the other hand, only has one way to get factored. So notice when the numbers are low, or if they're prime numbers, there aren't that many ways to factor them, and so the number of combinations is relatively low. So in this case, considering the possible things we have to check, we have 2 ways of doing this. There's only one pair of factors that works here, but we have to consider them flipped both ways. So if we take 2 times 1 times 2, we have a total of 4 things that we need to consider. That's not bad at all. So let's check out our possibilities. So we could say, as a first guess, that this would be 4x and x as the first term in each of the factors. And so the product of that would be 4x squared. Now, let's look at the signs before we move on. Since the sign on the 3 has to be positive 3, we need to both factors to be positive or both factors to be negative. Since the middle term has a negative sign, that tells us automatically that we must have a minus and a minus. So the only thing left to figure out is where to put the 1 and where to put the 3. since the 8 is relatively large compared to those numbers, we will probably want to try to, we need to have pretty big combinations. Okay, so a couple of things that I could try. I could put the, I want to probably put the 3 in the factor opposite to the 4, because that will give me a big number like 12. That would give me negative 12. And if I put the 1 right here, that would give me minus 1 more. Obviously, that difference is too big. If we switch them around, we end up, let's try the other way around. If I put 3 here and 1 here, and then I use the distributive property, I end up with minus 7x for a middle term, which is close, but not quite there. So the first 2 guesses were bad. They just didn't work. So let's get rid of the first 2 guesses. You write them back in there. We know that those are wrong, so that just didn't work. I can cross that out. You could erase it if you were working on your paper. And so that means we better try the combinations involving 2x and 2x. So we exhausted the possibilities for 4x and x. As we said before, we know it has to be minus minus. And now, since it's 2x and 2x, it really doesn't matter where I put the 3 and where I put the 1. And when you quickly check using the distributive property, the middle terms, you get a negative 6x and a minus 2x, so that the minus 6x and the minus 2x would give us exactly the minus 8x that we were hoping for. So this, in fact, is how we could factor the expression 4x squared minus 8x plus 3.